and we'll do it in both degrees and radians. So what is the difference between the first? So we want to find all the angles that make the equation true. So it's no different than solving any equation. You try to figure out what belongs in the equation that makes it true. But what's the difference about 1 through 3 and 4 through 6? What about the directions for 1 to 3 and 4 to 6? What's the only difference, Roxana? Yeah, the first one is in radians, the second is in degrees, and someone else said that you're going backward, which is exactly correct. Is the way you do this is you go backward. So what I'm asking is, remember sine is the y coordinate? Sine is the y coordinate. So I'm saying where in one rotation of the unit circle, where is the y coordinate root 2 over 2? So it really helps me to draw a picture. So where is the y coordinate root 2 over 2? Is it the short triangle, the medium, or the tall? It's right in the middle. It's the medium. So we know that's one place. Okay. And so we know that's one place. And what is theta in radians there? In the middle is? Pi over 4. Okay, pi over 4. Okay. However, there's another place where the y coordinate is root 2 over 2. And in other words, where else is the y coordinate positive? Because this is positive root 2 over 2. In what quadrant? In the second quadrant, right? Y is positive in the second quadrant, and it's all symmetric, so it's the same distance from the x-axis. And so this is actually easier in radians. What would that be in radians? 1/4, 2/4, 3/4, right? 3 pi over 4. So our two answers are pi over 4 and 3 pi over 4. Those are the two angles where the sine is root 2 over 2. So let's try this one. Where is the x coordinate? X coordinate a half. Is that the short or the tall? It's the tall one, yeah. So it's the tall one, and because you know that that's root 3 over 2 1/2, so you can see the x coordinate is no, that's the other way around, 1/2 root 3 over 2. So the x coordinate is a half. So what is that in radians? When you're far away, it's either over 3 or over 6. What's bigger, 1/6 or 1/3? They're the thirds. So it's pi over 3. That's one answer. And then where else is the x coordinate positive? And remember, this is the x-axis, this is the y-axis. Where are x coordinates positive? Quadrant 1 and 4, right? And it's totally symmetric. So it's the tall triangle there. It's in quadrant 1 and 4, where x is positive, right? If you were to plot a point in the coordinate plane, x is positive in those two places. So what would that be in terms of thirds? 5/3, 5 pi over 3, 5/3. Just one away from 6/3, which would be all the way around. So actually, I'm pleased that students are finding this to be easier in radians. All right, so you try this. Where is the x, just to yourself, where is the x coordinate -1 on the unit circle? Draw yourself a little picture, and then try to write down what the angle is where the x coordinate is -1. Okay, anyone? Yeah, Danny.
So it's like at the 180-degree angle or pi?
At pi, exactly, because the coordinates here are -1, 0. Is there another place where the x coordinate is -1? Nope. So there can be one answer. There can be one or two answers. Now let's try doing the same thing in degrees. So where's the sine negative root 3 over 2? In other words, where's the y coordinate negative? Is it the tall triangle or the short, where the y coordinate is root 3 over 2?
Short.
Should be tall, right? It was tall up here, right? Where the y coordinate is root 3 over 2. So it's the tall one. And which two quadrants?
3 and
3 and 4, yeah, 3 and 4. So we go tall triangles there. And so are the tall ones over 6 or over 3? Those are the thirds. So 1/3, 2/3, 3/3, 4/3, and 5/3. Yeah. So far, so good. Cosine is negative in quadrant. The x-coordinate is negative in quadrant 2 and 3, right? Because you go to the left in the x-axis. And it's going to be the tall triangle again, I believe. Yes. So these are thirds. So we get 2 pi over 3 and 4/3. Nice. And the last one, where the tangent is 0, is at pi and 2 pi. Yeah, or we would say, so we have to look at the directions. They say between 0 and 2 pi. I should have done this because otherwise you wouldn't know, you'd get like 3 answers. So it should have said less than. Can you just cross off the equal to symbol? So now what are your answers? Just pi or 0 degrees, right? 0 degrees and pi. Oh, sorry, gosh. 0 radians and pi. Because we're doing it in radians. So 0 radians and pi radians. We wouldn't include 2 pi again because we want the answers between 0 and 2 pi. So 0 and pi. Okay, now here's the thinking question. So I think you got that down. So the question is, do you have to use a unit circle for the sine of 30 degrees to be a half? Does that only work in where the radius is 1? Or like what if we did radius 5? Now is the sine 30 degrees? Let's find out. Let's just do what we understand, what we've been doing all along. Let's just make a right triangle. Make the hypotenuse 5. Let's label this 30 degrees. Okay, and now how do we find, so the sine of 30 degrees, we're missing the opposite side. How are we going to find that opposite side?
SOHCAHTOA.
Well, we can't do SOHCAHTOA because we're, actually, can we?
30, 60, 90.
If we want to find the exact value, we use a 30, 60, 90. So this is the hypotenuse. What's this side? We can just do it quickly. What's this y distance? Yeah, 2.5 or 5 halves, right? It's half of 5 or 2.5.
Yeah.
Yeah.
The bottom.
The long leg, no, the short leg is half of the hypotenuse, and the long leg is x root 3.
Yeah, so the bottom would be.
So let me draw it here. If it's standing up tall with the 30, 60, 90, you get 2x, x, and x root 3. It's not drawn to scale, so I think it looks a little bit weird, but that's it. So you get 2.5 over 5, which is 2.5 over 5 is one half, right? 1/2. So the ratio of the sides is still a half. The ratio of the sides is still a half. No matter, even if you don't use a unit circle, the ratio is still. Now the distances, the coordinates are different. It's 5. The coordinates of this point would be 5 halves. Would be whatever this distance is would be x and this is y. So the distances are different. So now, how do we solve this if the ratio is not something that's on our unit circle, like 0.4? How are we gonna solve that? So the answer is you have to use your calculator. So you would do theta equals inverse cosine, and you'll get your answer. Your calculator is already in degree mode. So if you hit the button above the cosine button, what do you get? It's only half the story though. So we're not done. It's not that simple. But what do we get when we do inverse cosine of 0.4? How many degrees? 66.4 degrees, okay? But is that the only place where the x coordinate is 0.4? That's one place, right? So it's about maybe right here. So that's 66.4. But where else is the cosine positive? Which other quadrant? Quadrant 1 and 4, right? So we also need this angle. So how do you find that? It's totally symmetric. How do you find the angle that goes to there? The easiest way is to subtract it from 360. There you go. So you do 360. Then now you're just using geometry. So 360 minus 66.4 is about
97.6.
okay. Thank you.
295.
Okay. So let's try another one. So let's do inverse sine of negative 0.39. So theta equals inverse sine of negative 0.39. And what do you get? Inverse sine of negative 0.39 should give you a negative answer. Negative 22 degrees, right? So about negative 22 degrees. So that angle is right here if you rotate in the negative direction. Why can't your calculator just give you both answers? Why does your calculator just give you one answer? Okay, the reason is remember the vertical line test? How many places can a vertical line hit a graph for it to be a function? Only one, right? So if your calculator behaves like a function, it can't say this or that. It can only give you one answer for it to be a function. So we have to use what we know about trig to figure it out. So here's negative 22 degrees. What would the equivalent angle be in the positive direction so that we can answer it from 0 to 360?
338.
338, right. So one of the answers is 338. So that's in quadrant 4. And then where else is the sign negative? In quadrant 3, right? So if this is, now we're going to use geometry. If this was 22 degrees, what is this angle here? What's the other answer? How do we find it? Good. You do 180 plus 22, which would be 202 degrees. 202 degrees. So those are our two answers for that. What about this? Why do you try 1.2 and hit inverse cosine, and what happens? Domain error, no solution. Why do you think you can't have 1.2? You're right. So the ratio of the side lengths can't be more than 1. Ratio of side lengths not greater than 1. And remember the graph that you did of sine and cosine? Remember the maximum was 1 and the minimum was -1? Cosine actually looks like this. It's like a wave, just like sine. It's just shifted. So the most you could have is 1 and the smallest is -1. If it's outside, you'll get no solution.